Hello friends, you must be wondering what I am playing with today, right? You too must have used such dice while playing games like Snakes and Ladders or Ludo, haven't you? Now, look closely at this die. Its 6 faces have dots 1, 2, 3, 4, 5, and 6. The real fun here is that we don't know which number we'll get on the upper face of the die 1, 2, 3, 4, 5 or 6 until the die lands. We can only estimate the possible outcomes. Of course, we are sure that the outcome will be certainly from 1 to 6. Now, can you tell me some similar examples? Okay, one example that quickly comes to my mind is the toss before a cricket match. Now let's toss a coin. Guess, head or tail? I think it's a head. Let's see. It's a head. Experiments of this kind in which all possible results are known in advance, but none of them can be predicted with certainty, and there is equal possibility for each result to be true, are called random experiments. The examples mentioned here, such as throwing a die or tossing a coin, are random experiments. Drawing a card from a well-shuffled pack of cards is also a random experiment. Here are some more examples of random experiments. Let's see. Adding the numbers that appear on the upper faces after throwing 2 dice. Then drawing a picture card from a well-shuffled pack of cards. Or selecting one card from cards numbered 1 to 10 with one number on each card. Okay, now tell me, is selecting an intelligent student from 40 students in a class a random experiment? The concept of intelligence can be different for everyone. Therefore, intelligence is a subjective concept. Hence, selecting an intelligent student from 40 students in a class is not a random experiment. Understood? Outcome. What is outcome? The result of a random experiment is called an outcome. In the random experiment of throwing a die, 6 outcomes are possible. 1 or 2 or 3 or 4 or 5 or 6. This is because the 6 faces of the die have the dots 1, 2, 3, 4, 5 and 6. A coin has 2 sides, head and tail. Therefore, when a coin is tossed, there can only be 2 possible outcomes, head or tail, right? Equally likely outcomes. Imagine what would happen if both sides of the coin had only head or only tail. Could such a coin be used for a toss? No, right? That's correct. Because such a coin will always show the same sign. Such a coin would be biased. If such a coin is used, the probability of getting the outcomes head or tail will not be equal. Then the players concerned will say, this is cheating, won't they? For the game to be fair, the possibility of the outcome being true must be the same for all outcomes, mustn't it? For the possibility of all the outcomes being true to be equal, The objects used in the random experiment must be balanced. Understand? While studying random experiment, we assume that the objects used are fair or unbiased. This means that in a random experiment, no outcome is obtained by preference, but the possibility of all outcomes being true is equal. Such outcomes are called equally likely outcomes. Or, in a random experiment, a given number of outcomes are said to be equally likely if none of them occurs in preference to others. In a toss, the outcomes head or tail are equally likely. Similarly, when a die with one number from 1 to 6 on each face is thrown, the possibility of any one of those numbers appearing on the upper face is equal. That is, all the outcomes of getting any one number from 1 to 6 are equally likely. Getting it? Sample space. The set of all possible outcomes in a random experiment is called the sample space. The sample space is denoted by the English letter S or the Greek letter omega. The number of elements in the sample space is denoted as NS. If the number of elements in the sample space is finite, then it is called a finite sample space. Now let's look at some examples. Okay? If one coin is tossed 3 times or 3 coins are tossed simultaneously, the sample space will be as follows. Sample space S is equal to HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. Therefore, NS is equal to 8. Now, let's see how to write the sample space when 2 dice are thrown simultaneously or 1 die is thrown twice. When 2 dice are thrown, we write the outcomes as ordered pairs where the number on the upper face of the first die is written first and the number on the upper face of second die is written second. If a single die is thrown twice, the number obtained in the first throw is written first and the number obtained in the second throw is written second as an ordered pair. The sample space will be as follows. S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. While writing this sample space, the number on the first die is kept as 1 and the numbers from 1 to 6 are written sequentially for the second die. Then, the number on the first die is changed to 2 and the numbers from 1 to 6 are again written sequentially for the second die. Similarly, the number on the first die is sequentially changed from 1 to 6 and each time keeping the number on the first die constant. The number on the second die is varied from 1 to 6. Therefore, NS is equal to 36. What did we learn? Experiments in which all possible outcomes are known in advance, but we cannot definitely predict which specific outcome will be obtained, and where the possibility of all outcomes being true is equal are called random experiments. Result of a random experiment is called an outcome. For the possibility of all outcomes being true to be equal, the objects used in the random experiment must be fair or unbiased. In a random experiment, no outcome is obtained by preference. Rather, the possibility of all outcomes being true is equal. Such outcomes are called equally likely outcomes. Exercise. Question 1. Which of the following examples are random experiments? 1. Selecting a student for a drawing competition from 50 students in a class. 2. A bag contains balls of red, blue, and yellow colors in equal numbers. Picking one ball without looking into the bag. Question 2. How many outcomes are possible in each of the following random experiments? 1. To form a 3-digit number using the digits 4, 5, 6 without repetition of the digits. 2. A jar contains marbles of red, yellow, green, blue, white, and purple colors. The number of marbles of each color is equal. A marble is to be picked without looking into the jar. The color of the picked marble is to be recorded. 3. One fort is to be selected for a fort sightseeing trip from the following forts: Raigad, Rajgarh, Pratapgarh, Sinhagad, Shivneri, Panhala, Purandar, Harishchandragarh. Question 3. Write the sample space S and the number of sample points NS in it for each of the following experiments. 1. The calendar for the month of August in the year 2025 is shown here. Finding the day of the week for the dates that are multiples of 4 in this month. 2. Selecting an ice cream of any 2 flavors from vanilla, chocolate, lemon, orange, mango, pineapple